Late afternoon winds had already begun pushing through the downtown corridors when pedestrians in the Eastern District noticed something unusual while crossing an otherwise ordinary intersection. Paper debris that had been sliding along the street simply stopped when it reached the next block. It did not slow or change direction. It halted at an invisible boundary surrounding a single city block and remained there, resting in air that no longer moved. The surrounding streets continued behaving normally. Flags on nearby rooftops snapped in steady gusts. Tree branches along the avenue swayed with the same rhythm reported across the entire city weather network. Yet inside the block, bordered by 4 mid-rise office buildings and a public library, the air stood perfectly still. The contradiction became difficult to ignore within minutes. Wind was measurable everywhere around the perimeter. Inside the block, it vanished. Urban meteorology teams first encountered the anomaly during a routine airflow review tied to a construction project several streets away. Engineers were verifying wind tunnel simulations against real rooftop sensor readings to predict turbulence around a planned high-rise tower. Most stations confirmed expected conditions: steady lateral wind pushing across the district. One cluster of rooftop anemometers reported something else entirely. The sensors installed atop the library and 2 adjacent office towers indicated sustained zero movement in the air column. Not a lull, not a fluctuation, a complete absence of atmospheric flow. At ground level, the effect was visible without instrumentation. Plastic bags carried by the wind along the avenue reached the block and settled as though striking a transparent wall. Dry leaves collected along the curb line but never crossed into the interior streets. Pedestrians stepping from the windy sidewalk into the center of the block described an abrupt change similar to entering a sealed room. Yet the buildings were open to the sky. Air should have moved freely through the grid of streets between them. The architecture offered no enclosure, no canopy, no barrier capable of blocking regional wind patterns. Meteorological staff initially considered the possibility of local turbulence caused by the arrangement of buildings. Certain street layouts can generate zones where airflow weakens due to opposing vortices, but those effects remain unstable, shifting as gusts pass through. The quiet air inside the block did not fluctuate. Wind flowed around it. Drone footage collected from a nearby news station helicopter confirmed the pattern with unsettling clarity. Lightweight debris lifted by gusts approached the block from the west and curved away before crossing the street grid. The path of the debris traced smooth arcs around the perimeter, as though deflected by a pressure field invisible to cameras. Inside the boundary, the air column remained motionless. By early evening, urban airflow specialists had begun comparing rooftop pressure readings across the district. The surrounding city showed normal gradients consistent with the day's weather system. Within the 4-street boundary, the gradient disappeared entirely. Pressure equalized to a stable condition across the entire block. Without a pressure difference, wind had no force to move it. The problem was that pressure equalization normally requires enclosure. This block had none. Several technicians suggested a calibration problem affecting the rooftop instruments. Replacement handheld sensors were carried to the center of the block to verify the readings directly. They reported the same condition. The air column displayed no lateral motion. Smoke sticks released at multiple street corners provided a simple visual test. The plumes rose vertically and then hung in place, forming thin gray pillars that did not drift. Outside the perimeter, the same smoke plumes stretched horizontally with the wind. The boundary separating the two conditions appeared almost geometric. Standing on the corner of Alder and 9th, an observer could extend one arm into moving wind and keep the other in perfectly still air. The transition occurred across a distance no wider than the sidewalk. City engineers began mapping the boundary that evening by releasing biodegradable marker powder from handheld dispensers while walking the perimeter streets. Each cloud of colored particles behaved identically. Gusts pushed them along until they reached the interior street grid. Then the particles stopped. The accumulation formed a faint ring of debris outlining the edges of the block. By nightfall, the pattern had become unmistakable from above. Traffic cameras looking down from nearby towers showed a square zone of unmoving air surrounded by the normal turbulence of downtown wind corridors. Nothing physical occupied the space. The effect was purely atmospheric. Weather stations across the metropolitan network reported unchanged regional conditions. Wind speed remained steady throughout the city. No pressure systems or thermal inversions could account for a single isolated region where airflow ceased completely. The stillness persisted through the night. Streetlights inside the block illuminated drifting dust that simply hovered where it rose. Car exhaust lingered longer than expected before gradually diffusing upward. Even the usual microcurrents generated by passing vehicles seemed unable to produce horizontal motion. Air displaced by movement appeared to settle immediately rather than propagate through the block. The quiet air began affecting building systems by the following morning. Office towers surrounding the library relied on exterior wind pressure to assist their ventilation systems. Normally, intake vents on the windward sides of buildings pull fresh air through ducts using the pressure difference created by outdoor gusts. Inside the block, those pressure differences had disappeared. Ventilation systems began compensating automatically, increasing mechanical fan output to maintain airflow through the buildings. Facility managers initially suspected equipment malfunction until they compared exterior readings with neighboring districts. Outside the block, wind pressure remained strong. Inside, the atmosphere behaved as though it had reached equilibrium with itself. Meteorologists expanded their measurements vertically by launching several small weather balloons from the center of the block. The balloons rose normally, drifting upward through the quiet air. At roughly 200 meters above street level, the balloons suddenly began drifting eastward with the prevailing wind. The transition suggested the suppression zone had a vertical ceiling. The air below that height remained still. Above it, normal atmospheric motion resumed. That discovery narrowed the anomaly's physical volume to a roughly cubic column extending upward from the block's perimeter streets. Within that column, lateral air movement did not occur. Outside it, wind moved freely. Throughout the second day, researchers attempted to model how such a condition could exist. Some proposed the presence of a localized electromagnetic interference field affecting charged particles in the atmosphere. Others suggested a rare thermodynamic equilibrium produced by underground heat gradients. Neither explanation held up to measurement. Temperature inside the block matched the surrounding district within normal variation. No electromagnetic anomalies appeared on nearby monitoring equipment. The air itself remained chemically identical to the rest of the city. Only its motion had disappeared. Late in the afternoon, the phenomenon revealed a second behavior that complicated the initial assumption of a static field. Meteorologists released a series of lightweight sensor balloons from the west side of the block, while the wind continued blowing steadily from that direction. Each balloon drifted toward the perimeter at a predictable speed. Upon reaching the boundary, the balloons did not stop. They rose slightly. Then they slid along the invisible edge of the block before continuing north. The motion resembled a current diverting around a submerged object in a river. Air approaching the block did not penetrate it. It flowed around it. The pattern repeated from every direction tested. Wind encountering the boundary redirected smoothly along the perimeter streets before continuing past the block. The quiet air inside remained unaffected. That behavior confirmed the anomaly was not simply a calm region sheltered by buildings. The wind field itself appeared to reorganize around the space. By evening, city officials temporarily closed rooftop drone traffic above the district, while aviation authorities reviewed the vertical boundary discovered earlier in the day. Though aircraft normally flew far above the anomaly's ceiling, its existence introduced an unknown variable into the airflow patterns surrounding downtown. The closure provided an unexpected opportunity for further observation. With fewer disturbances overhead, atmospheric monitoring drones were deployed along the block's edges to study how the wind interacted with the boundary. Several drones hovered just outside the perimeter while releasing thin streams of vapor into the moving air. Each vapor trail bent smoothly around the block's edges without crossing the interior streets. One drone briefly crossed the boundary while maintaining altitude within the suppression zone. Its propellers continued generating thrust, allowing it to move freely through the still air. However, when the drone stopped actively pushing itself forward, it no longer drifted with the wind. It simply remained suspended where it hovered. The surrounding gusts never reached it. From above, the block now appeared as a perfectly stable pocket of atmosphere embedded within the larger weather system. A motionless volume of air held inside the moving wind of the city. The stillness had persisted for nearly 40 hours, and sometime during the third night, the quiet block demonstrated that it was not merely a passive region where wind disappeared. It adjusted. By the time environmental engineers returned the following morning, the boundary surrounding the still air block no longer aligned with the original streets. The change was subtle at first. Marker powder that had accumulated along the southern sidewalk during the previous day now rested several meters farther into the intersection. Lightweight debris that had outlined the perimeter had shifted slightly north. Wind still flowed normally through the surrounding district. Inside the block, the air remained perfectly motionless. But the boundary separating the two conditions had moved. The adjustment was measured carefully throughout the morning using handheld smoke emitters and rooftop cameras. Each test confirmed the same pattern. The suppression zone now extended several meters beyond its original limits along one side of the block, while receding slightly along another. The interior streets, where air had stood still the previous day, were unchanged. Only the perimeter had shifted. The movement introduced a complication that earlier explanations could not easily address. A localized thermodynamic condition tied to underground infrastructure would have remained fixed to the physical layout of the block. This region of still air appeared capable of repositioning itself. Environmental analysts began overlaying the new boundary onto detailed city maps. The shift did not correspond to any underground structures, transit tunnels, or electrical corridors. It followed a slightly different pattern. The new perimeter aligned closely with the airflow path that wind normally used when navigating between the surrounding buildings. Instead of occupying the original square defined by the streets, the suppression zone had adjusted itself along the natural wind corridor created by the architecture. Wind continued bending around it. The quiet air continued occupying the same volume. But the position of that volume had slid sideways along the urban grid. The effect remained difficult to notice at street level unless someone was actively testing the wind. Pedestrians walking through the district experienced brief transitions between gusts and still air that felt like stepping through invisible doorways. From above, however, the shift was unmistakable. The still region had moved. City engineers considered whether the change might represent a temporary atmospheric fluctuation that would gradually dissipate. For several hours, the boundary appeared stable in its new position. During that period, another operational system began reporting an unrelated problem. Air quality monitoring stations surrounding the district had begun detecting elevated concentrations of vehicle exhaust lingering near street level. Normally, wind disperses these pollutants rapidly through the city's airflow corridors. Inside the suppression zone, that dispersal had slowed dramatically. The still air was beginning to trap emissions. Urban environmental staff initially expected the effect to remain minor because the block contained mostly office buildings with limited traffic. However, a major bus corridor ran along the western boundary of the anomaly. During peak traffic hours, exhaust that normally dispersed downwind began accumulating near the curb lanes. Sensors positioned several streets away detected no change in pollution levels. Only the streets bordering the still air zone showed the increase. The anomaly had begun interacting with the city's environmental systems. Engineers attempted to simulate how the trapped air might behave if wind conditions intensified later in the week. Models predicted that stronger gusts would simply divert more aggressively around the suppression zone, leaving the interior air unchanged. The models did not predict what happened next. Shortly after midday, rooftop cameras captured a new movement along the northern edge of the block. The boundary separating moving wind from still air shifted again. This time, the adjustment occurred gradually over several minutes. Windborne debris that had been sliding along the pavement slowed, then stopped several meters farther north than the previous boundary line. The quiet air expanded across half the intersection before stabilizing again. The interior streets now occupied a slightly larger volume than the original block. Meteorologists began testing whether the anomaly might be responding to atmospheric pressure changes associated with the day's weather system. However, pressure readings across the district remained stable. The expansion did not coincide with any measurable environmental shift. More puzzling was the direction of the movement. The boundary had expanded toward the bus corridor, where pollution levels had begun rising earlier that morning. Wind continued pushing exhaust toward the suppression zone. Instead of dispersing, the emissions accumulated briefly along the boundary before rising vertically through the still air column. The process produced an unexpected visual indicator. Sunlight striking the trapped particles revealed a faint vertical haze hovering above the interior streets. From certain rooftop angles, the block appeared capped by a barely visible column of suspended dust. As the afternoon progressed, the haze thickened slightly, making the suppression zone visible to anyone looking down from the surrounding office towers. Below that vertical column, the air remained motionless. City environmental officials responded by rerouting several bus lines away from the western boundary to prevent further pollutant buildup. Traffic adjustments reduced the immediate concern, but introduced a logistical complication. Several transit routes had relied on the corridor for decades. Closing it indefinitely required coordination across multiple agencies. Meanwhile, the anomaly continued behaving in ways that suggested it was not entirely indifferent to the environment surrounding it. Late in the day, one of the atmospheric drones hovering near the perimeter attempted to measure airflow gradients just outside the boundary using fine tracer vapor. As the drone approached the edge of the suppression zone, the vapor stream bent sharply along the perimeter before dispersing into the surrounding wind. The drone repositioned itself several meters away and repeated the test. Again, the vapor curved along the boundary without entering the still region. After the third attempt, the boundary shifted. The adjustment was small, no more than 2 meters, but it placed the drone just outside the quiet air column instead of within it. Ground observers confirmed the repositioning using handheld smoke sticks moments later. The boundary had moved. The drone operator repositioned again and repeated the measurement sequence from a slightly different angle. The vapor stream approached the boundary, bent along it, and dispersed. A few seconds later, the boundary slid another meter away. The movement was subtle, gradual, and perfectly consistent. Each time the drone attempted to hold position near the edge of the still air column, the boundary adjusted just enough to place the aircraft back in moving wind. No one suggested that the anomaly possessed awareness. Yet the correlation between measurement attempts and boundary movement remained difficult to dismiss. The adjustments never occurred when the perimeter remained undisturbed. They appeared only during active observation. Over the following week, atmospheric researchers conducted controlled experiments using remote-release tracer particles and autonomous drones programmed to approach the boundary without human input. The same pattern repeated. Wind bent around the perimeter. Air inside remained motionless. Whenever instruments attempted to stabilize themselves within the boundary for extended measurement, the edge of the suppression zone drifted slightly until the instruments returned to moving air. The shifts never exceeded a few meters, but they occurred with consistent timing. By the end of the second week, the quiet air column had expanded gradually beyond its original block. The perimeter now encompassed portions of 2 adjacent intersections while receding slightly along the southern street. The overall volume of still air had increased. Meteorological authorities eventually classified the phenomenon as a localized atmospheric suppression field. The designation carried no explanation, only a description of the observed behavior. Urban planning agencies adjusted traffic flow through the district to minimize emissions entering the region. Several rooftop weather stations were permanently reassigned to monitor the boundary's position. Daily wind forecasts for the city began including a small advisory note for the Eastern District, indicating the presence of the calm zone. Commuters passing through the area gradually became accustomed to the sensation of crossing from gusting wind into silent air. Leaves sliding along the pavement continued stopping at the invisible perimeter. Smoke plumes rising inside the district continued standing upright before dissolving into the upper atmosphere. Above the rooftops, the city's weather systems moved exactly as they always had. Below that ceiling, one section of the urban sky remained perfectly still. And every few days, the boundary moved again.